welcome back. This is our third video on limits. Our second last video on limits, you could say, except for that we will be using limits when we get into the next unit. But very exciting. I think for sure we're all doing well. I hope we are at least. But today we're going to talk about limits that equal infinity. You might say this is easy. Just say all these equal infinity. But I've threw a few tricks in there. You have to prove why they equal infinity. So here we go. Let's see here. Limit as x approaches 0 for 1 over x. Now we know that if x is approaching 0, let's say from the positive side, we've got 1 over 1, let's say. Then we've got 1 over 1/2. Then we've got 1 over 1/3. We keep going. And so what we see is we're dividing 1 by an increasingly small number. And so once that number gets small enough, what's going to happen is we're just going to get positive infinity. But what if we approached it from the other side? Well, we've got 1 over 1, 1 over negative 1 over 2, 1 over negative 1 over 3. What are we going to get? We're getting an increasingly negative number. So what we're going to get is negative infinity. And so for that reason, this limit, doesn't exist. I'll just put equals d in e. Equals does not exist. It doesn't actually equal it. I'll actually get rid of that equals sign. It doesn't make any sense. And why? Well, we'll write down why. It's because limit as x approaches 0 from the positive 1 over x does not equal the limit as x approaches 0 from the negative of 1 over x. That's why. So, not too bad. But, what if we square this value on the bottom? Like right here. What we're going to get is we're going to get these same numbers, except we're going to square these. So we're going to get 1 over 1 over 1. 1 squared is just 1. We're going to get 1 over 4. We get 1 over 9. And so we can see that, again, approaches positive infinity. But what if we square negative 1 over 2? We're going to get the same value. And so for that reason, this limit exists because the left and right limit equal the same thing. And so it equals positive infinity. So, two pretty easy ones. We could actually say that the limit as x approaches 0 of 1 over x to any value will not exist if that value that x is being raised to is odd, and it will be positive infinity if it is even. So, let's use this to evaluate this. So, what we're going to use here is our limit laws, which I did forget to go over a bit, but they're pretty simple. So all it is if you have the limit of as x approaches 0, or anything for that matter, of a function times another function, you can just split the limit across. And same with addition. So I could split this up into two different limits if I wanted to. But yeah, we can also do it if, say, this was all squared. We could just take the limit of the inside and then square it. It would be the same thing. So yeah. That's only if that's not raised to a function. If it's raised to a function, you'll have to take the limit of that function as well. But pretty simple stuff, pretty intuitive, just regular algebra type of stuff. But this this limit looks a little more confusing to me. So what's going to happen, so what we're going to use is we're going to use that, not power law, product law, sorry. And we're going to get the limit as x approaches 0 from the positive of 1 over x times 2 minus x times x minus 4 over x squared minus 7. So what are we going to get here? Well, we know that the limit as x approaches 0 from the positive of 1 over x we found over here. It's positive infinity. So what we've got to do, spread that out a bit too much, but I'll make this 2 a little better. What we've got to do is we've got to plug 0 into this equation because it exists over here. So what we've got is, we've got the limit as x approaches 0 from the positive, of course, because otherwise it wouldn't exist, as we found up here, of, we'll plug our 0 into here, so we'll take our 1 over x, 0 squared minus 7 is negative 7 over 2 minus 0 is 2 times 0 minus 4 is negative 4. So all we've got is the limit as x approaches 0 from the positive of, well, we've got negative 7 over 8x. Or no, we'll keep it split up. Negative 7 over 8 times 1 over x. Sorry, I knew I should have checked that. It's actually just 7 over 8 because we have 2 negatives. And so we're going to use another limit law here that I actually forgot to talk about this one as well, which is if we have a constant, we can pull the constant completely outside of the limit because there's no x value in there, so nothing's going to happen to that. So all we've got is we've got 7 over 8 times, well, 1 over x, limit as x approaches 0 from the positive is just infinity. And any positive number times infinity is positive infinity. So, easy stuff. And that's all I've got for you guys. It's really all there is to those. I mean, there might be other situations where you have to use conjugates, or you might have to, use one of those other things we talked about in other videos, but in terms of just evaluating limits that equal infinity or negative infinity, or, that's really all I've got for you guys. Anyways, well, see you in the next video when we're evaluating limits at infinity, which is very similar, but not quite the same. Thank you.